In this video, I will introduce what is separable differential equation and how to solve a separable differential equation when given an initial condition. So yeah, we're going to learn about separable differential equation, and this is calculus 2. Okay, so what is a separable differential equation? A separable differential equation is a first-order differential equation in which the expression dy dx can be factored as a function of x times a function of y. So for example, dy over dx equals f of x times gy. Good example could be dy dx equals to negative x times y. Okay, so that is how you know you have a separable differential equation. So how do you solve for separable differential equation? So remember, as we recall, the solution of a differential equation is an equation or equations. So we got to solve for y. So first step is get all the x on one side and all the y terms on the other side. What I would do is cross multiply. That's the first step I would do. Then once you have all the x's and all the y's on one term, you're going to integrate on both sides of the equation. And then step 3, solve for y if possible. Okay, so let's do an example. So let's say solve the example 1 says solve the differential equation with the given initial value problems. We have dy over dx equals to negative 4x times y squared, and we have a condition of y of 0 equals to 1. So did you also know that this could also be expressed as 0 over 1? So if that helps, you can write it like that. So what would I do? So first I would check it, is it separable? It is. It is in terms of f of x and g of y. Okay, so the next step is get all the x's and y's on one side. So how would I do that? I would cross multiply. Some people will get rid of do another way, but I like cross multiplying because there's only two sides. So this 4xy squared does have as a denominator 1, so I'm going to cross multiply. So 1 times dy is dy. And then negative 4x, this whole thing times this, that would be negative 4x y squared dx, correct? So it's still not, we don't have all the terms of x and y's on one side. What I have to do is let's get rid of this y squared, move it to the other side, and then that'll give us all the x's on one side and all the y's on one side. So let's do that. So let's get rid of this y squared by dividing both sides by y squared. So this cancels. So now you're left with 1 over y squared of dy. You could put dy in the middle. It's the same thing as the top. And then on the right, we are left with negative 4x dx. Okay. So as you can see, we all have the y's on one side and all the x's on one side. So the next step is to integrate on both sides. So I'm going to integrate, well, how am I going to integrate 1 y squared? So maybe I can rewrite 1 over y squared as a negative power. Maybe that will help for integration. So you can say y of negative 2 dy. Integrate on both sides. Okay, so let me put it here. What's the integration of y to the negative 2? You just use power rule. Negative 2 plus 1 is negative 1 divided by itself. And then now, because we have a initial condition, we do have to add that plus c, but you could just put the c or the c1 on one side of the equation. It doesn't matter. I think I'll just put the c on the other side. Then on the right side, what is the integration of negative 4x squared? It's negative 4x2 over 2. And then you can add that c1. Okay. So now I'm going to clean this up and try to solve for y. So y to the negative 1 is 1 over y. And then negative 4x squared divided by 2 is negative 2x squared plus c1. Okay. Should I solve for my c1? Yes, I think we can do that before we solve for y. So let's solve for a c1. So we have a condition of initial condition of 0, 1. So you can replace x with 0 and replace y with 1. So it's negative 1 over 1 equals negative 2, and then x is 0 plus c1. So negative 1 divided by negative 1 is negative 1 equals to c1. Okay, so our c1 is negative 1. We're going to need that. Okay, so now we're going to go back to here, and somehow we're going to have to solve for y. Maybe I'm going to have to cross multiply, right? So 1 times negative 1 is negative 1. Y times that whole thing is just y times that whole thing. We can replace c1 with negative 1, right? And then what I'm going to do is solve for y. Now I can. All I have to do to solve for y is get rid of this by dividing both sides by itself, right? Plus a negative 1 is really negative 1, right? So we can just write that out. Okay, so this cancels. So we're left with y equals negative 1 over negative 2x squared minus 1. And we already solved our c, so we don't need to add that c1. You can write it like this, or because this negative, you can factor out a minus and put it like in the center or in the bottom. And then if you do that, your equation would be positive 1 on the top. Bring down this, FOIL out this negative, this invisible negative 1 to the denominator. So that would be positive 2x squared plus 1. Okay. So this answer is correct, or you can use this answer. It's the same thing. Okay, so let me just recap. First step is figure out if it is it separable? Yes. The next step is I cross multiplied. Then the next step is get all the y's and all the x's on one side. The next step is once I did that, I took the integration on both sides. Then what I did was I tried to solve for my constant by plugging in my initial value, and I got c1 as negative 1. And then the last step was somehow solve for y, and it's possible. Okay, that was example 1. I think there's 2 examples on this lecture. So go ahead and pause, and we are moving on. Example 2 says solve the differential equation. So we have dy over dx equals square root of x over e to the y. Now we got to check it is differential. Is it separable? Yes. Even though it's not in a it's not like in the f of x times g of y form. You can rewrite e to the y as e to the negative y. That's makes it separable, but I'm just going to leave it like that. And I am going to, so I know it's separable. Now the next step I'm going to do is cross multiply. So go ahead and cross multiply. So this is e to the y dy. And then on the right, it's square root of x dx. So is everything in terms of x and y's on one side? I believe so, it is. So the next step is we're going to integrate both sides. If you want, because we're going to integrate on both sides, how can I rewrite square root of x as a power? I can rewrite that as x to the 1/2. Okay, now we can integrate. So on the left side, integration of e to the y, it's pretty simple. It's just e to the y. On the right side, how do you take the integration of x to the 1/2? So you just add 1 to the power. So 1/2 plus 1, or 2/2, is x to the 3/2 divided by its power. So you can rewrite this as x to the 3/2. It's like a complex fraction divided by 3/2. Cross multiply, so this would be 2x to the 3/2 over 3, right? And don't forget your plus c, or c1. Now in this example, we do not have an initial value, so we don't have to solve for c1. Okay, so now we can just try solving for y. Can we get y by itself? I believe so. We have e to the y to the left, so how do I get rid of this e? You're going to have to take the inverse of e. So you're going to multiply both sides by ln. Okay, so on the left, ln er inverses, so it just becomes y. On the right, it's just ln of 2/3 x to the 3/2 plus c of c1. Okay, and I think that's it. So this was a more simpler one. Okay, they can get more complex as we do more problems. So let's move on to the third one. See if it's harder than the other. So example 3, solve the differential equation with no initial condition. So we have y prime, y apostrophe, or y prime equals y squared times sin of x. Is this separable? I believe so, because this is like a multiple, f of x times g of x. Or yeah, f of y times g of x. But this y apostrophe, how can I rewrite that y prime? That could be written as dy over dx equals to y squared times sin of x. Okay, now it's much better. Now I can get all the y's on one side and all the x's on one side. So I'm going to cross multiply. So this has a denominator 1, so 1 times dy is dy. On the left side, it's just y squared times sin of x. And then this is all times it by dx, right? Now what to do? I want to get all the y's on one side and all the x's. So the sin x dx is good. I just have to get rid of this y squared, move it to the other side, and we'll be good. So to get rid of it or move it to the other side, I'm going to divide both sides by y squared. Okay, so now on the left, you can express it as 1 over y squared dy. And then on the right, this cancels, and then you're left with sin of x times d of x. Much better. Now I can take the integration. But before I do that, let's rewrite 1 over y squared as a negative power. So you can say y to the -2 dy equals to sin of x dx. Okay, now just go ahead and take the integration of both sides. So how do you take the integration of y to the -2? It's just -2 plus 1, which is -1 divided by its power. And then on the right side, what's the integration of sine x? You should know that. That is negative cosine of x. And then we do have to add that, our constant. Okay, let's now try to solve for y. So y to the -1 over -1 can be expressed as 1 over y. Then you still have this negative. And then go ahead and try to solve for y. So what I would do is cross multiply. So 1 times -1 is -1. And then y times that whole thing is and then solve for y, so you're going to divide both sides by itself. I mean, to solve for y, you divide both sides by this whole thing. Okay, so this cancels. So you're left with y equals -1 over okay. Or because you have this minus, you could put that minus in the bottom and distribute that. So you can also say y equals the 1 becomes positive, and then if you distribute that, that's positive cosine of x minus c1. So this is fine, and this is fine. Okay, so that was like the first taste of separable differentiable equation. On the next video, we'll probably do more complex, more examples of separable differential equation, but most likely with more difficult integration rules. So that'll be in the next video. Okay, I will stop here. Thank you.